So this is the HCP agent app that I've created. These are the default email and password. So here we have a form that will be filled by the HCP. So we just need to automate this using multi-level agent system. So here we have fields like HCP name, interaction type, date, time, created by the name of the HCP. So it is John Smith right now. And attendees that we can add, topics that were discussed in the discussion. And meeting types can be of these phone call, email, conference, or a meeting. Interaction type can be of these. And the materials shared are some of the materials. So this is yeah. So these are some of the materials that we have. Sample distributed we can attach, and the sentiment that was inferred or observed by the HCP agent. And the outcome of the meeting, and there are some follow-ups that we can do, and AI suggested follow-ups. So when we do the AI interaction, it will provide some of the follow-ups according to the agent's prompt, the HCP agent's prompt. So we will have those follow-ups here. So let us see how to use the AI assistant. Here we have some of the queries that we can have. So these are some sample queries. So we can first search for all the materials that we have. So we request for the materials. It is a multi-level agent, so it is going through the chains. So for that we can see the LangGraph server. I've quite maxed out the limits today. Hope it works for the queries. So these are some of the nodes of our agent. It starts with the request. It starts with the request, identifies the intent of the user. Then according to the intent, it extracts all the required entities. And for those entities, it also enriches those entities with the correct value. So the user query might not be very much accurate according to the database user. And we need some accurate data to process it to the orchestrator. So we extract and then enrich all those entities. And we pass it to the orchestrator. Orchestrator has multiple tools. All of these nodes have multiple tools, and according to that, the method that it has to call orchestrator has to call. And after it is correct, it will hit save. Yeah. So now it is saved. We can see the network call. So when we hit save, it pushes all the form data to the backend to save the interaction. And with this, we have the follow-ups. We can add the follow-ups. So follow-ups can be related to the interaction or cannot be related. So these are the follow-ups that are related to this interaction. So it will have a relation with the interaction in the DB. Else we can have it as none also. Like if an HCP just opened and created a new interaction, erase all the data. If we click new interaction, it erase all the data. And then he can have some manual follow-ups, or he can create a follow-up from here directly. So it didn't create any interaction, it created a follow-up related to any data or any HCP. So that won't be related to the interaction ID. So that wasn't the interaction that was created. That's it. And apart from that, we can have some updates on the interaction. So if we want to update this, and one more thing to specify that it's a fuzzy search. So even if we have partial values of the HCP, it will get to know whom we are talking about. So it will update the last meeting and add that as requested mode on Google samples. So the nodes are like this, and after orchestration, all the operation, it formats the response and returns the response to the chat, front-end chat that we have. Yeah, so it was like this. It is updated and it's asking do you want any to set any other follow-up or something. So we can see those in the follow-ups also. Follow-ups keeps updating and it has updated some nodes related to the thing we just said. And it's like this. You can see the response log. The intent that was classified was this, and HCP that it detected and resolved. Since we said Dr. Sharma, it resolved to this. The date time was taken from here itself, and the previous values. These were these were the previous values. The date time meeting. Sentiment was positive, was also the previous value itself, and the new values are these. So we will need to hit save, and then it saves the response. And let's see the code of this. So we can see here front end is like setting the form data using Redux and the slices that we have to dispatch all the actions, like setting the name and the materials and all of the other data. So these are the dispatch actions for all of those. And in the backend we can see we have the main intercom the main, and in main we have when we make an agent call, so it routes through the agent routes, and in agent routes these are some intermediate parametric base models that we use for the data, the backend data. These are some internal functions, extract and AI solution. So here provides some solution, so it extract and format all those things. It build interaction data, it's related to that. These are the routes. We have chat route. So and then it gets the agent. So get agent is initializing the LLM that we have. So get HCP agent. The HCP agent is agent. So HCP agent is here. So we called for get agent, get HCP agent, and what it does is initializes the LLM manager and passes that LLM manager to a current HCP agent. LLM manager what it does is select the available model that we have according to preferences that we have. So model selector, these are some of the chat models and tool call models. Tool call models are something that we haven't used. I will tell the reason. And these are the model selector. So because tool call models require some subscription, or we can directly eliminate the passing the tools to the AI, and we can just ask the AI what all tools and what all sequence we have to execute. So that can be done by us. So we provide the data, we ask for what all tools to execute. We have the requirements from the data that are required for the tools. Tools have a tools registry. We will see that also. And here is a agent instance. So when we do get HCP agent, it selects when we have provided open router and provider. We can have Groq, open router, and any of this, and the APIs. For open router, it does is what it does is select the open router models in sequence. So we have some of the chat models. So whatever that is available on the platform, so it selects that, and after that it returns that agent. So after that we have the HCP agent that will be redirecting our chats to the selected model. So this is a plug and play kind of thing where you can switch the models from the LLM manager itself. And HCP agent, what it does is whenever it initializes, it creates a session related to the user. So it will create a session, and the session is something that is in the memory. So we will see that also. So in memory, we have all the collection of sessions and user ID mapped to the current session. So this creates a session, and in memory, we have all of the sessions for all of the users. So I have used an in-memory data currently. And get sessions, we have it gets the session with the session ID, and these are some of the basic extractions that could have directly been done by the AI. But just to reduce the cost, I have done this. And the process thing is here, so it gets a session. If there isn't a session, it creates a session, add the user message, and first node was to classify intent, as we have seen here. It classifies the intent. So here it classifies with confidence. So there are multiple intents that it can have. So we can see it in the intent classifier or base also. So these are some of the entities that we have in the database. So these are the models, and agent config are these. And its task is to classify intent classifier. Its task is to extract entity validator to validate and enrich entities. And the tools that we have provided to all of these agents are search HCP, and all of these tools, like here of the search HCP. And for intent classifier, we didn't provide any tool. So it just infers from the user input and the system prompt that we have provided. System prompt for the intent classifier. So these are the valid intents that we have. So apart from this, if it is not supported, it's unknown. And for unknown, it will ask the user to explain your, to describe the operation that you want to do in a bit brief. So here we have other tools that are provided and all of the agent type, and the settings are also there. We have customizer tokens because intent classifier will provide a shorter response itself. And token varies for all of the models, and we have orchestrator. They should have been inside a variable itself. And these are the tools. So orchestrator is the main thing. So it does most of the operations. So these are the tools that are provided to the orchestrator: searching LCP, getting LCP ID, creating interaction, updating interaction. So what we did was update here. So this was a create one, and we can have a search HCP also, like to show the details of this doctor. And creating follow-ups. Yeah, the follow-up AI agent that we have, it is processed through a follow-up. The orchestrator that does the follow-up, and get follow-ups and update follow-ups, all of these things. Clear session is also there, recommend materials, search materials. So first operation that it did was search materials itself. Yeah. So these are the operations that it does. There's the base agent. It initializes, sets it in the local variable that is the manager that was provided with. Initialization, it gets the model, and all of the things are here. And complete is an method that is and rather than abstract method, so it is extended in the rest of the implementations that are derived from the base agent. So we can see that here. So intent classifier is there. So it extends this. So process is extended here. Over again. Entity validator, and yeah. So there is the validation prompt that it builds. So it provides some examples and all of the things in the prompt. These are the prompt parts. This will extend with this and create a prompt and then validate. It will validate the HCP and all of the things. And so the code is like this. Similarly, for intent classifier, we have here it builds the message for the input and the context and the prompt that is there for the intent classifier agent. And if it gets a response, then it returns it, else it returns the response for the unknown. Means intent classifier will classify it to the operations that we have. So these are the intents that it will classify, else if it doesn't, so it will be unknown, else cached as unknown. Okay, intent classifier. Yeah. If it tracks it as unknown, so from here itself it will to else for the intent unknown, it will do the intent classification again. So it is like this. It returns the confidence, and there is a threshold. If it exceeds the threshold, then only it will be executed. It will pass through the chain. After intent, we extract the entities. In entities, we extract all the fields that we have. So, as we have seen, these are some of the fields that can be provided by the user. So, it will provide the system and get and JSON response with extracted fields. Any of them can be none also. So, entity extractor. Yeah. Okay, so it extracts the entities, and here we have entity validator. It validates the entities. So since here he had provided like Dr. Sharma, it will extract the name of HCP as Dr. Sharma, and after that it will enrich the entities with the actual value from the database. I have kept the layers for doing operations directly from here, and the tool executions not by the LLM, by us itself, getting to know which of the tools to execute and then executing the tools. These two layers, the tool layer and the DB layer, not DB layer, and the DB layer are the things that does change in the DB. Okay, so yeah, so these are the things that does change in the DB. So we have routes. So some of the routes are connected. Yeah, so there is not much of a fragmentation and isolation in the operation. So the DB operations are written in the routes itself. So that is to be separated, and we have tool service. In tool service also we interact with the database. So it is different from the route, but we can, in further versions, we can have an integration of both, all of the interaction of with the DB, and also doing the operation like search HCP and all those things. The DB layer returns all of the HCPs that are present. We have some of the fields that are exposed. So only over those exposed fields only, yeah, these are the exposed fields, only over which the user query will be applied, and not on the other fields. It is like this. So these DB fields, all of the fields are not exposed to the user. So these are some of the things that user can interact with. Yeah. That's it. And we have set up LangGraph, LangChain, and conversation memory. We have it creates session. There's a dictionary of the user ID and the session data. And we have a get session to the session, add message to the session. So I get the session message. Is the message, it creates a log and appends the message to the session. So it is like this. And we have tests also. I've used Graphify also to have a log of the changes and the graph representation, so it can be referred easily by the agent coding agent that I'm using. So it's like this. And there is a check DB also, so we can check. So we have a script to check the database. So here we are checking the database. I do this and not so these are the things. So we did an update. So update for the new sample. So these are the new values. And like that, we have this was the audit log that we have. Any updates that are being made will be audited. And apart from that, we have the interaction data and everything here. These are the follow-ups. The follow-ups that we created, the 3 follow-ups that we created. These are those. This is a previous data.